The ocean carries sound farther than light. A ship on the surface can be seen for miles in clear weather, but a submarine moves beneath, where vision ends within feet. Detection depended on hearing what could not be seen. Naval crews monitored the water through mechanical devices that amplified distant vibrations. Hydrophones were lowered over the side or mounted in the hull. Listeners wore headphones and sat in designated compartments, isolated from engine noise and conversation. They heard propeller beats, hull friction, machinery hum, all transmitted through seawater at speeds far exceeding sound and air. The listener's task was to separate intentional movement from natural ocean noise. There was no visual confirmation. The threat existed only as a pattern of sound, intermittent and directionless until interpreted. Entire defensive operations began with a single reported bearing. The listener did not see the enemy, he heard it, or believed he did, and that belief determined action. Hydrophones were passive receivers. They consisted of piezoelectric crystals or carbon microphones sealed in waterproof casings, designed to convert pressure waves into electrical signals. These signals traveled through insulated cables to listening stations inside the ship. Early devices were non-directional. Sound arrived from all angles, requiring the listener to distinguish source location by subtle differences in timing and intensity. Later arrays used multiple hydrophones spaced along the hull or towed behind the vessel. By comparing the phase difference between sensors, operators could estimate a bearing. The equipment was mechanical and required constant calibration. Headphones delivered raw audio with minimal filtering. Listeners heard everything the ocean transmitted: biologics, weather, distant traffic, structural vibration. Volume controls were limited. Amplification introduced distortion. The devices did not interpret. They only conducted sound from water to air, leaving analysis to the human operator. Training began with recorded examples. Listeners memorized the acoustic signatures of known vessels, the blade count of specific propellers, the rhythm of diesel engines, the grinding of reduction gears. Each submarine class produced a distinct sound profile. Repetition built recognition. Trainees learned to ignore surface clutter and focus on subsurface frequencies. They practiced in simulated environments where instructors introduced overlapping noise. The goal was auditory isolation, the ability to hold one sound in attention while others continued. Experienced listeners could identify a contact within seconds of first detection. They noted cadence, harmonic content, modulation patterns. Some could estimate speed and depth from propeller cavitation alone. The skill was not innate. It developed through sustained exposure and required continuous practice to maintain. Fatigue degraded performance. Distraction caused missed contacts. There was no technological substitute for disciplined listening. Bearing estimation was communicated in degrees relative to the ship's heading. The listener reported contact position as a compass angle, often with a confidence qualifier. Uncertainty was inherent. Sound refracted through thermoclines, reflected off the seafloor, scattered around underwater terrain. A bearing might shift several degrees as the contact moved or as environmental conditions changed. The listener's report went to the bridge or operations center, where it was plotted on a chart. Multiple contacts required simultaneous tracking. Coordination between listeners on different hydrophone arrays allowed triangulation. If two operators reported the same signal at different bearings, the intersection suggested a location. This process was slow and prone to error. A submarine changing course could invalidate previous estimates within minutes. Communication was verbal and brief. Listeners used standardized terminology to avoid ambiguity. They did not speculate beyond what the sound suggested. The system depended on disciplined reporting and careful interpretation by command personnel. Naval patrols were planned around acoustic coverage. Ships followed routes that maximized hydrophone exposure to expected threat corridors. Depth, speed, and heading were adjusted to reduce self-generated noise. Engines were throttled back during listening intervals. Crew movement was restricted in adjacent compartments. Entire vessels operated in near silence to improve detection range. Convoy escorts relied on listeners to provide early warning. Defensive formations were arranged to overlap acoustic zones. If one ship lost contact, another might still hold it. Anti-submarine operations began with an acoustic detection. Depth charge deployment, evasive maneuvers, and engagement decisions all originated from listener reports. There was no independent verification. Naval Command trusted the accuracy of trained operators because no alternative existed. The listener's judgment carried operational weight. A missed contact could result in torpedo attack. A false report wasted resources and exposed the patrol to actual threats elsewhere. Listening shifts lasted 4 to 6 hours. Longer periods caused auditory fatigue. The brain's ability to distinguish fine acoustic detail degraded with sustained concentration. Operators reported phantom contacts, sounds that resembled threats but originated from equipment vibration, biologics, or psychological expectation. Rest intervals were mandatory but not always sufficient. Sleep deprivation accumulated over days at sea. Some listeners developed tinnitus from prolonged headphone use. Others experienced auditory hallucinations during extended silent periods. Error rates increased under stress. A tired operator might miss a genuine contact or misidentify a friendly vessel. There was no automated backup. The system had no redundancy beyond assigning multiple listeners to separate hydrophone arrays. Physical and mental endurance became limiting factors. Training emphasized stamina as much as skill. The profession selected for individuals capable of sustained auditory focus, but even the best operators experienced performance decline during prolonged deployments. Active sonar transmitted sound pulses and measured their return. The technology existed in early forms but became reliable and compact only after sustained development. Electronic systems replaced human interpretation with oscilloscope displays and automated ranging. Detection no longer depended on recognizing a distant propeller. The operator sent a ping and observed the echo. Range, bearing, and relative motion could be calculated with precision. The transition occurred rapidly once the equipment proved effective. Listening stations were decommissioned. Hydrophone arrays remained in use but fed data to electronic processors rather than headphones. Trained listeners were reassigned or left naval service. The skill became obsolete within a decade. There was no formal recognition of the transition. Ships simply stopped depending on human ears. The ocean continued to carry sound as it always had, but no one needed to interpret it manually anymore. Mechanical hydrophones were removed or left in place, inactive. Listening compartments were repurposed for storage or converted into electronic equipment rooms. Headphones and amplification units were cataloged and placed in naval archives. Some equipment was transferred to research institutions. Most was discarded. A few older vessels retained passive listening capability as a backup system, but operators rarely used it. The infrastructure of acoustic detection remained visible for years after the practice ended. Mounting brackets, cable conduits, and soundproofed walls marked the locations where listeners once worked. These spaces were not ceremonially closed, they simply stopped being staffed. New crew members passed through them without understanding their function. The profession left no tradition. There were no reunions, no published accounts, no monuments. It had been a necessary task performed under specific technological constraints, and when those constraints changed, the task ended. Naval doctrine shifted toward electronic systems without preserving manual techniques. Training programs were discontinued. The knowledge held by experienced listeners was not formally documented. Some operators wrote personal notes, but these were scattered and incomplete. The skill could not be easily taught from written instruction. It required guided practice and direct exposure to ocean acoustics. Within a generation, no one remained who had performed the work operationally. Historians noted the existence of acoustic listening in technical summaries of anti-submarine warfare, but few details survived. The equipment was described, the procedure was outlined, the experience of sustained auditory monitoring, the cognitive load, the uncertainty, and the methods used to manage fatigue and error were not recorded. The profession disappeared from institutional memory as thoroughly as it had from active service. Submarines continued to operate beneath the surface. Ships continued to search for them. The methods changed, but the objective did not. Detection became more reliable, faster, and less dependent on human endurance. The ocean remained opaque to visible light. Sound still traveled through it, refracted by temperature gradients, scattered by terrain, absorbed by distance. Electronic sonar listened in ways human operators never could, processing signals too faint or too fast for biological hearing. The work of monitoring the sea continued without the listeners who had once performed it manually. No ceremony marked the end of their service. The equipment was simply replaced. The compartments were reassigned. The ships moved through the same waters, tracking the same threats, but the task no longer required a person to sit in silence and wait for a sound that might indicate something hidden below.